For our systems model, we drew inspiration from Lewis Scarra's novel, Holes, which was also made into a Disney movie.
It was an easy choice for us to make, as the book was a childhood favourite for the both of us.
The book centers on an unlucky teenager boy named Stanley Yelnats, who is sent to a juvenile camp in a desert in Texas after being falsely accused of theft.
The plot explores the history of the area and how the actions of several characters in the past have affected Stanley's life. These interconnecting stories touch on themes such as racism and homelessness.
The scene that we turned into our model was Stanley digging into the ground, which is a common occurrence throughout the story.
This book is suitable for upper primary students and could be adapted to fit the Year 5-6 Design and Technology content description of the Australian curriculum, as it involves investigating characteristics and properties of a range of materials and systems and evaluating the impact of their use.
It also links to the Year 6 content description of humanities and social sciences, exploring cultural diversity. Additionally, this task links to English within the Australian curriculum as it allows students to discuss social and cultural context while understanding and interpreting different texts.
Our model consists of a variety of materials that are easily accessible and available within a classroom. When designing our model, we first put together a list of materials and equipment that would be needed for the construction of the project.
The base of the model is made out of a pre-made timber box purchased from Spotlight. It is light, so easy for children to move around the classroom. However, is strong enough to withstand careless treatment from students. The backboard of the model is a small sheet of MDF which we stuck to the box using hot glue and clamps.
In the planning phase, we collaboratively created a design brief which included a clear sketch of the intended final product, as well as the measurement limitations of the model, 40 cm by 40 cm by 40 cm. The MDF background and other elements of the model were painted. Trees and bushes were cut out of cardboard and stuck together and to the base using hot glue, assuring they would remain in place. We purchased a character with movable body parts, making it easy for children to maneuver his placement when using the model. The character is dressed in an orange jumpsuit made out of a piece of fabric, just like the outfit worn in the book. Dead grass and leaves were used to decorate the trees, providing a dry, remote nature to the model. Glue was smeared to the base prior to adding dirt. The dirt is a representation of the conditions that Stanley worked in throughout the book. Small rocks were hot glued to the base, surrounding the meeting point of the split pins. The treasure chest is an important feature of the book and was included in our model to pique the interest and curiosity of the students. The two systems that we used in our model were electrical and pneumatics. The pneumatics pushes the shovel down past the character's arms and into the ground. Once the shovel touches the ground, it completes the electrical circuit, which switches the light on, located in the center of the sun. Pneumatic systems use the energy stored in compressed air, which for our model creates a push movement. To successfully produce this movement, you need two plastic syringes and a connecting tube. One end of the plastic syringe was connected to the shovel using hot glue. The middle of this syringe was hot glued to the hole in the MDF, holding it in its exact place. We drilled two holes in the MDF sheet, one for the syringe and one for the light in the sun. We did this using a battery-powered drill. The rest of the system was hidden behind the sheet using glue and tape. Most of the wires consisting of the electrical circuit are also hidden behind the sheet, stuck on with tape. This includes the light bulb, which is lodged in between a 10mm packer, holding it in a perfect position. The rest of the wiring, along with the battery, are taped underneath the base. Two wires are attached to the battery. One is connected to a split pin that has been poked up through a small hole and hot glued to the base, while the other wire is connected to the light bulb, running along the back of the MDF sheet. Another wire is connected to the other side of the light bulb, which has been slid through the hole in the sheet and glued to the shovel. A split pin has also been connected to the end of this wire. As the energy from the pneumatic system pushes the shovel down, the two split pins make contact, successfully completing the electrical circuit. Blue points were used for safety when connecting pieces of wire together. This ensured there was no exposed wire that could potentially harm users. Upon reflection, an improvement that could be made to our model is finding alternative ways of sticking things together, such as the use of Velcro. The use of hot glue limits the ability to take certain elements apart and fix them if necessary. Overall, we are pleased with the outcome of our systems model project, as it clearly meets the criteria of incorporating two working systems. Here is the reference list for our project.